We're going to be talking about a bunch of tools in work and workflows inside of RoadEng in the context of forest engineering projects. We're going to be looking at roads, landings, cable harvesting, and a newer tool of ours coming in our next version called digital planting. I should mention two of these in particular, roads and landings, actually still really relevant for other industries. So I can see from our webinar attendee list, we've got wind farms, we've got mining, we've got a bunch of folks doing some general civil engineering projects. So two of the elements are going to be really relevant, and those other two, I'll make sure to give you a heads up, but great opportunities to refill your coffee cup. So thank you everyone for joining us here today. My name's Erin. You've probably heard my voice before on a webinar, but if this is your first time joining in, welcome. So our webinar agenda basically is the plan on the page here. We're going to go through the 4 sections, but before we can really get into talking about any of these sort of projects, let's talk about what software we're playing with today. So we are using our RoadEng with Softtree Optimal version. So that's kind of like our everything product. It's got the earthwork optimization tools in it to make Matt's life a little bit easier, especially when he gets to the roads. We are going to be working in the terrain module for the majority of these projects, but we're going to be doing so using the newer version 12 terrain module. And then from there, we'll head into the location module with the roads to finish them off. And with that, the very first part of our webinar is really about the project setup. So before we can get into the actual tools, we need a model. So we're going to spend a couple minutes now showing you how to import some data, bring in some block boundaries, and adding in an ortho photo.
So I'll start out in terrain. So of course we'll go to location later on, but terrain is where we'll do a lot of our exercises for today. Now I'm going to click Insert File, and the first thing that I'm going to do is bring in my topo data. So in this case, I have a DEM that I'd like to bring in, and we'll do that. We have our projection set on import. We'll bring in all those points, and we'll create our tin model at the same time. I'm going to just click off to the side. We'll go over to our 3D view to really see what we're dealing with today. So we are dealing with some pretty rugged topography, and to add a little more context to it, we're going to bring in those block boundaries that Erin mentioned. So here I just have a shapefile. Could be a wide variety of different formats, or it could be something that we draw in the software, but yeah, save the boredom of watching me draw things. We'll bring in some pre-existing line work. Now here I'm going to just change this so I'll make it a little easier to see for everyone. And there we are. So on this particular project, we have 3 block boundaries, one out here, one up here, but really for this exercise, I'm just going to be focusing on this one here. Now, with this, and I'll add a little bit of extra context, we may want to have an ortho image or other imagery in the background. So for that, I could click Import, and we could hit Save, and we could download some ortho imagery so we can see that as we're working and have a better feel of what's going on out there. Now, I could hit Save. If I do that here, it's a fairly large area that we're dealing with. Take a minute to download. I'm going to cheat. We are going to add that image in as a background terrain. Now, a couple other things that we may want to do for context. Well, right now, I don't have any contours. If I wanted contours, I could generate those. Now, I'm not going to here just because I can use the 3D view and the ortho image to really have a good understanding of what's going on. But then the other thing that I may want to consider is streams. So if I wanted to, or if I had it, I could import our own line work for streams, but in this case, I don't have that line work. So I'm going to just go up here. I'm going to click Streams and Ponds, and I am going to calculate, well, streams and ponding areas on this topographic surface. And there we are. We have a bunch of blue lines to show us where the streams likely are. And with that, I think I'm at the point where I'm kind of set up. I'm seeing everything that I want to see as I kind of go through and plan my block and my roads and my landings and what have you. So with that, I'll pass it back to Erin.
Perfect. Thank you, Matt. And I think it's important to share, obviously, that was a really fast introduction. We got that project set up, and I think that was like 2 minutes. All of the content that Matt went through in that section, if you need it in a little bit more detail, or perhaps you want to see it for a different type of data source, we do have lots of videos available on it. But let's get to actually what we're planning to talk about today, which is those 4 tools. And the first tool that we're going to start off with today is cable harvesting. So if you are a flat terrain forestry person, or perhaps you are in another industry, this is your coffee refill moment. Enjoy it. So yeah, we're going to get into cable harvesting. So to start, a little bit about what cable harvesting is, which obviously is going to be, the planning of where to put our cable harvesting equipment. And on steep terrain, it does really require careful planning. So choosing the right harvesting method, the right equipment, and putting it in the right location are all really, really important. So we're going to be taking a look at a few different components of cable harvesting as we put it into the terrain module, into the cable harvesting section, in order to understand if we have a suitable spot for it. So we're going to take a look at the type of yarding system we're going to use. The different types of yarding systems can be like skyline, high lead, grapple yarders, and really depending on your terrain and your requirements, you're going to adjust that system. We also have the physical piece of equipment we're using. It could be a tower, it could be a yarder. And we're going to be working with and inputting that into the software and setting up both our logging system and our equipment. Those are sort of 2 big things to set up. We also have the cables, the skyline, the main line, the haul back line that we're going to pay attention to and include in the configurations. Of course, we've got the carriage. And then the piece that I think is definitely worth mentioning, the other component of cable harvesting is which calculation method we are going to be using in order to do the cable harvesting analysis. So today we're focusing on just one method, which is minimum deflection given load. But we have an e-course. So if you're interested in learning about all the cable harvesting details, all the cable harvesting aspects, I should say, in more detail in the software, we've got a great course. It takes about 2 to 3 hours to complete. You can get at it through softry.thinkific.com. If you're a client on support, reach out to us. We'll get you a free access code to make it so that you can learn at no cost. But we go into all the different calculation methods here and all the different details of setting it up. So with that, kind of rambly intro to cable harvesting. Matt, I'm going to pass it back your way.
So we have our block that we're focusing on here, and obviously a pretty important part of logging it is figuring out how we're actually going to get the wood. So we have up here, cable analysis tab. And I'll do a little clicking around here before I kind of add more context. So if I wanted to, I could click this. I could choose the logging system that I want. I could say, well, I want to go with a minimum length of, well, X distance. I can say I want to use, well, this as my max load. And we could hit OK. And now we can click along. And as we click along, we can see this graphic updating. And what that graphic is showing us where we could yard without losing our deflection, so losing our lift from that particular point. And once I had a location that I was really interested in and kind of unpacking and better understanding what we're up against, I could click accept, and we can see, well, where we're at. And if I wanted to change things, well, I could just click delete, and maybe we move it around a bit more, or maybe we add others. We can see the red is where we're kind of pushing ground lead. And well, we'll hit accept, and there we are. So we could see that if we kind of stacked these along our route, and maybe we wanted to have more radial lines coming off, we could absolutely fill this in and really have a good understanding of what we can reach from any particular location and really flush out the idea of where my landings should be or what I can get from my landings. Now, with this, of course, I'm clicking along and kind of relying on stuff that I didn't really give any context for. So one, there's this logging system that we're using that I've called LC650 with grapple. And what that is well, I've got my equipment. So I've previously added in my equipment. And in this case, I've given it my working tensions, my weight per length of my wire rope, and my max length. And then I've given it a system. So I can click add or edit, and I can see here that I've said that with that LC650, I'm using a running skyline setup, and my carriage weight is about 4,000 pounds. So this is all of the kind of the inputs that's required for this to be really easy to use as we get going. So both our equipment and our logging systems are not something that we typically set up every time. It's you set it up to represent the kind of the fleet or your contractor's fleet that you have access to, and you hit save as default, and then those appear in the list the next time you open them up. Now this particular example that I'm looking at, and I've kind of made it quite cluttered with all these D lines overlapping each other. I'm just gonna do some cleaning up here. But it is relatively gnarly spot. So if we kind of just look here, one, I can see I've got some existing roads just in the old ortho imagery. I've got some fairly steep ground up top here, and I guess we'll look at it in both. So fairly steep ground up top here, and I have this more benign terrain at the bottom. Now I could absolutely take this and run with it in the case where I want to use this existing road that's kind of mid-slope, and we could see when we used that D-line Explore tool, we had really good coverage, especially down slope to well, give us the lift we'd like to make our lives easier. But this is not exactly an easy block to log. One, we might have lift if we keep the road in the existing location, but two, we really don't have much room to deck wood. So if we wanted to explore other options, we could use these tools to do that and maybe explore a location where it'll give us, well, lots of room to deck wood and maybe even build out a nice big landing to make our lives easier. And then the other side of it, aside from just the decking challenges, well, it's really steep along here. We can see that the existing road has failed in some spots, and even upslope here, we've got this failure here. So aside from just advantages of having more room to deck wood, well, we might be able to avoid some really difficult terrain. That's risk. And then the other side of it is down low here. Well, if we had a road down here, there's probably a lot of this block that we could change from being purely cable block to allowing us to do some land-based logging. So for this, if I just want to quickly add a little context to that land-based side of things, if we want to have a good feel for how much of this block is under X% slope, and I'm going to use kind of 40% as my cutoff here. I could go up here. So I've got my block boundary selected. I'm going to hit polygonize. And I'm going to do this just on this feature that I have selected, so within that area. And I'm going to calculate anywhere that we have all slopes over, and let's go slopes over under 40%. So 0 to 40, I'm going to make them yellow. We'll hit OK. And we can see, well, we've actually got an awful lot of that block that we could shovel log or hoe chuck if our road was down here. and looking at how that really looks on the 3D, yeah, it makes sense. So here, if I wanted to see, well, if I had a road down here, where would it make sense to put my landings? I could use that same tool. So that tool being the D-line Explorer mode, or I could just draw in individual lines, move them around and see, well, what I can yard from a particular place. Now, just as a quick sidebar here, I could hide these and select these individually, but one thing that we don't touch on very often is the fact that we also can work with the layers here. So if I just want to take those layers and turn them off, I'm going to just select those features by the layer that they're on, and I'm going to turn them off here. Now, to do that individual D-line analysis, instead of coming up here, I'm going to go new feature. I'm going to just give it a name. I'm going to make that feature draped. So I'm going to turn off the elevations, but leave on modeled. We'll come down here and we'll say, well, maybe we want to go from, say, here all the way up to here. So if we want to see kind of what that ground line does underneath that line that we've just drawn, we can click the profile button and voila, we can see the ground line underneath it. Now, if we wanted to do the D-line analysis just on this individual feature, I'll tile this so it's a little easier for folks to see everything. Well, we could come over to the cable analysis tab and we can click new and we can say, well, I want to use that logging system that we were previously using in D-line Explorer mode. You can go there. We're going to use that minimum deflection given load. And let's calculate where our backspar would be if we have a butt rigging it. So if we had that block just hung on stump down slope. So we can see we can't quite make it up to the existing road here. But again, if we were kind of looking at, well, how can we use these tools to make more informed decisions? Well, maybe we could have a mobile backspar walk around along that existing road. And we can see, well, we're able to use that at pullout and we're getting a bit more lift to run with. So we can use that and then we could try it. Well, what happens if we pull this along here? Great, we can see we're keeping our lift. But if we tried to go way over here, we can see, well, we're not quite able to make it to that back corner. So again, all about making more informed decisions, and we can use this really anywhere we'd like. If we wanted to maybe put our landing here and pull that around here, it's all very interactive, so we can see what we're up against. So here, I'm going to just move that back to there for a little context, and I'll pass it back to Erin before I go into kind of the next step.
Perfect. And I love the transition. You mentioned landings, which is where we are going next. So landings, essentially spots where we can gather and store wood. They, provide space for equipment, whatnot. And we tend to shape and grade those areas to support their needs. Now, there are a few different ways to create a landing in Roadenge. The landing method that we're going to look at today is the standalone sort of bulk earthworks options. This is going to be as a graded site in terrain, but you certainly can create a landing leveraging a shape from terrain and then using that as a reference feature in our location module, or you could maybe even create it as a widening. But as I said, today we're going to focus on this sort of standalone method inside the terrain module. And with that workflow for creating this sort of graded site has really, two key terrain files that are going to be involved, which is a little bit different than some of the other elements where we were just looking at cable harvesting. It's all in that same terrain. So here we are going to take that existing topo that Matt has created and been working with and showing us, we're going to throw that in the background of a new terrain. So topo surface in the background, and then we are going to create our new site design inside of a new terrain. And the reason we're going to do that is because we are going to be creating a shape and then grading it to that terrain. Now we can grade it to that terrain at a fixed elevation, or there's an option as well to leverage a really cool tool called grading auto balance. And what that's going to do is it's going to move the site up and down, trying to figure out where the best spot is to balance cut and fill and balance our earthworks. So our next part of our webinar, and I feel like this is a content overload. So yeah, everyone, this is being recorded. You can go back, check it out. We also have full in-depth webinars on pretty much every topic here. But this one, going back to Matt, gonna go take a look at landing.
So as Aaron introduced, we need two different surfaces, and our terrain files are gonna be, well, hold those surfaces. So in this case, I'm gonna save the file that I've been working in. I'm gonna just call this topo. So that's going to be my topo surface. And we're going to open up another instance of terrain here. So in this file, I'm going to right click, plan options, background, and I'm going to add in that topo file that we've just saved. And we'll hit zoom to extents so we can see up here where we're dealing with things. Now, you don't have to do this, but it is nice, especially in this case, to add a little context of what we're dealing with. So I'm just going to make in my 3D view that I can see that topo surface as a surface. I'll make it so we can see through it if we're in cut as well by changing the alpha channel. So there we are. And if we want to design our landing around here, well, we could just come in here. We could say, give it a name. We could basically draw in whatever shape we'd like to represent those kind of top of pad geometry. Or we could do something a little more kind of geometrically regular. So I'm going to go with something that's kind of a fixed dimension in this case. And I'm going to say, well, I want to have something that is, let's make it 60 meters by 20 meters. So I'm just defining that geometry tabularly. I'm going to bring that back around. We'll close that feature, and we could take it and we could move it into position. And here, well, I probably don't want it to be shaped, turned that way. Maybe I want it to be that way. And maybe I want it to be right like that. Now, if I go to my 3D view here, well, that isn't very nice. I'm kind of floating way up here in space, and I probably would rather that be closer to the ground. Now I'm going to set my elevation first. So if I wanted that to be right at this elevation, I could come up here and I could say, well, let's shift that down to be 50 meters elevation, and we could run with that. We could take that feature that we've drawn and we could do our grading from it. So with that feature selected, I could go grading. I could grade to the outside. I'm going to target our topo surface. I can set my cuts and fills to be whatever I'd like. I can tell it to interpolate slope lines and calculate volumes. So here I could see, I'll make it so I can see my surface here too. Here I can see that, well, if I left that at that elevation, we're set. We could run with that, but those volumes aren't ideal. I've got way more fill than I do cut, and usually the cheapest way to build something like that is just use the material on site. So instead of putting that in with a fixed elevation, I'm going to tell the software to figure out what elevation makes the most sense to balance my cuts and fills. And here, if I want to, I can move it around a little bit more as well. Kind of refine that. And only difference, rather than going to terrain modeling, grading, we'll go optimization, auto balance. Everything's the same, except I get to say, well, how much material do I want to end up with as a surplus? We're shooting for 0 here. So we'll hit OK this time. We'll let the software do its thing. It'll run through, try that landing at different elevations until we've got something like that, where we can see our cuts and our fills are balanced, so we don't have to import an extra fill to build out our preferred geometry. So I'd just save this, we'd call it landing, and we have our landing set up as its own entity. And with that, I'll pass it back to Erin.
Awesome. Thank you, Matt. Okay, we are actually looking like we might be on time. We're moving into topic number 3, roads. And this is one that, of course, we have a lot of depth in terms of webinars and content. So again, today, an introduction. This introduction is really going to focus on sort of two key parts of the road design process. The first of which is really about where do we put the road? How do we determine the best location? So here we're going to stay in the terrain module and we're going to figure out using Path Explorer, where's the best spot to put the road that meets all of our needs and constraints. So Path Explorer and terrain, from there, head over into location, and here is where we're going to take a look at, now with that road, what does the actual detailed geometry look like? What do the curves look like? What are the drainage considerations? Take a look at our mass haul volume estimates. And if you haven't seen last week's mass haul webinar, I think it was particularly excellent at explaining and talking about mass haul concepts. So tiny plug, check out last week's mass haul webinar. And then finally, we'll take a look at, quick creation of construction documentation for a road. So again, roads, we're going to play in both modules, start in the terrain, landscape level, head over into location, take a look at the detailed geometry. And again, we're keeping this on the lighter, simpler, higher level side, just given that we are covering 4 different topics in one webinar. So with that, Matt, let's add a road to our project.
So I am back in our topo file. And yeah, I know I want to get to at least here. So I'm going to run Path Explorer. So with this, I'm going to just define a new feature. And we'll draw it in with our mouse. So sure, we want to go from, well, actually, we'll go a little further back here. We want to go from there to there. Now with this, we can come over to the optimization tab. We can click Path Explorer AI, and we can set this up. So we can tell the software that I want to have no curves that are tighter than a 35-meter radius turn. We can change our grades to be whatever we'd like. In this case, I don't want to have any cuts or fills that are greater than 5 meters, and I'm quite content with our cuts and fills. Now, I probably do want to account for streams in this case. So I'm going to just say, well, I do have streams, they're polylines. And I'm going to say that those stream crossings are going to be, $4,000 a pop. So we'll hit OK. We can control this a little bit more. We can say, well, I want this road to be starting out pointed in that direction. And I want it to come into our landing from that direction, and we'll let her go. Now, this is one of those things that not instantaneous, but for what it is solving, it is extremely fast. So we'll let it go here for a bit. Eventually, this is going to say unlikely to improve, and we'll hit cancel. Unlikely to improve, great, we're set. We can see we've got, well, I asked for 5 different options. So I've got 5 different options to get to that landing. Now, we could go off of the cheapest, and we could look at these Path Explorer solutions, and we could go by name, and we could see, well, according to the metrics that we've given it, that one's going to be our cheapest solution. And, well, we could run with that. But if it happened to be that this one was the cheapest solution, well, maybe we wanted to swing out so we have a little bit more lift for adding other landings further back and kind of making it easier to log this. But in this case, I really do like that cheapest solution. Now, the other thing we could do is, and in this case, I'm kind of content logging this block, kind of opening up the top road until it gets difficult, having this lower road in to give me my access. But if we zoom out, and it won't be the same project, but making sure I'm not kind of painting myself into a corner, and that I can keep access so I can eventually get into this other block for a future development, well, I could quickly check that and make sure that what we have planned works. So I'm going to say B to C, and we can come in here and we'll go from there. And let's pick a spot in this block that's going to kind of make sense. So if we want to make sure we can get into that block and kind of the upper reaches of it without having to open up this road that we're trying to get away from using, well, we can use Path Explorer to kind of do that high-level future proofing too. So same idea. The only difference is I don't want to remove my possible solutions here for the other run, so I'm going to turn that off. We want to use, well, I don't really care the direction that is assumed at the destination side of things, but at the start I want this to be pointed in either of these directions. We'll hit OK this time. Same thing, we'll just get other solutions going out further and kind of dealing with kind of more complex terrain, at least. Yeah, peace of mind for future development.
And if you're watching this webinar feeling like it's unfair that we're showing you something in a version that's unreleased, this is my tiny plug. If you're a client on support, you can get access to some of the new stuff that we're showing today in our beta program. I will put a note in the chat here if you're interested in joining it. Please let us know. We're happy to get you on board, let you do some testing.
And I don't think I'm showing anything that's not in the beta version that our support clients have access to. So yeah, we've ran that, so we can be pretty comfortable that we are not painting ourselves into a corner. From this point, we totally can get up to that existing road, and we can see that, well, once we're there, it largely does follow the pre-existing road and then extends off of it. So again, peace of mind is nice to have. Now, going back to the main focus of what we're dealing with here, I'm going to just worry about the road for this particular block. So I'm going to save this file, and we are going to go over to location, where instead of considering it as a really smart line that's considered the problem as a whole, if it makes sense to go through something with a big through cut, it will. If it makes sense to go around it, it will. But let's take this and turn it into a proper model and design geometry. And we'll pop open location here. We'll click new file, we'll click browse. And let's grab that file that we've set up. So I want to use that selected Path Explorer feature as my initial alignment. And there we are. Now I'm going to do a few things to kind of get this set up to be appropriate. Now, right off the bat, I want to have curves and tangents rather than a polyline. So for that, I'm going to go in here, polyline to alignment. Great, we'll let that go. then we can, well, take this proper horizontal alignment. We can make sure our cross-section geometry that we have applied is appropriate. And in this case, it is. So standard gravel road, 6 meters wide with a 30 centimeters of surfacing. And we'll do a vertical optimization on that. So here, I'll put in my criteria. Let's try to keep our grades to that. If we have any control points, we'll add them in. We'll click process, we'll click run, and we'll let this solve for the optimal vertical alignment that's going to well, balance our earthworks and take into account the cost to move that material to build out our road. Again, kind of like Path Explorer, this is a big problem for in terms of kind of computational difficulty. So it's not instantaneous, but it is very quick for what it's doing. And we should see a solution here momentarily. So there we are. We can kind of zoom out here. We can see what we're dealing with for our grades. We've got that adverse road coming down, getting close to 12%, which was the max grade we used here, but largely around 8%. We can see our mass haul, very small cuts and fills. We can look at what we're dealing with in the 3D model. Looks good. Of course, we could go through and add our culverts in wherever it makes sense to add those. So if I want to add a pipe, say right here, well, we could add that in. We're set. Now I could check, see how much dirt we're moving. So about 6,000 cubes. And then if I wanted to produce some documentation here, I could come over to multiplot. We could quickly open a book layout, and voila, we've got that plan over profile, our sections all within a matter of minutes. So again, as Aaron introduced, kind of keeping it high level, not diving into too many of the weeds here, but yeah, we've optimized a road alignment and have a full design here in a matter of minutes. So I'll pass this back to Aaron. And,
Okay, last but not least, we're going to take a look at the new digital planting tool. So I feel like this one's an important one to have a little bit of context first for why we're talking about it and kind of how we got here. So this tool was originally developed with the New Zealand Forest Growers Association to really help them plan where to plant trees. Now, we actually did it originally supporting them sort of through manual design inside the software, and this was time consuming. So our development team saw an opportunity to really automate that task, improving the solution quality and of course the speed. So now we can use RoadEng to help us figure out where to plant trees and steeper slopes to support the mechanical harvesting limitations. So step one in a digital planting workflow, create that terrain model. And we've already done that in today's webinar in that sort of setup step. So we'll leverage our higher resolution LiDAR or DEM data, build our tin surface. From there, again, another step that we've done today, which is inserting our block data or perhaps creating features to represent our block boundaries. Following that, we're going to leverage the other tool that Matt also already demonstrated today, which was the polygonize tool. So here we're going to leverage terrain analysis tools to discretize different polygons based on their slope aspect. Once we've got those polygons, we're going to select them, and then we're going to set our planting parameters, number of trees per row, minimum number of trees per row, I should say, the distance between trees, the distance between rows, run the tool, and then it's going to give us our digital planting output in the form of individual tree features being created inside of our block boundaries. Again, super useful for getting tree counts for planting, useful for being able to plan that mechanization from the planting or the thinning or the final harvesting. And so with that, I'll pass it to Matt.
Now here, before I kind of just continue off from where I was at, I'm just going to hide some of that line work that I've been showing from previous steps. So for this particular kind of tool, well, there might be other or different things that we want to account for. So one, if we wanted to just account for kind of where those slopes were less than 40%, well, we could use those polygons that we had created, and we could run the tool on those. So they still exist, I just have the display property turned on. Now in this case, I'm not going to use it just where we have slopes under 40%. I'm going to kind of use the tool to kind of think ahead a bit here. And well, maybe we want to have, well, plan our planting to help support tethered systems in the future. So I want to have my whole block kind of cognizant of, well, having rows of trees that favor the rows running up and down the slope rather than running side hill where we have that cross slope that can create a tip over hazard. So with that in mind, I'm going to just select my block boundary. I'm going to go up to feature tools. I'm going to use that polygonize tool again. So here I just want to run on my currently selected feature. Now this time I don't want to generate my slopes. I want to generate aspect. I'm going to generate aspects. I'm going to create kind of whatever is appropriate for your project. I'm going to go with 7 intervals. So we've got our intervals created here. We'll hit OK. So we can see a bunch of different polygons. And I'm going to use those polygons to define my tree spacing. So I'm going to select those polygons. I'm going to do it by layer. I could do it by name or go through and select individuals if I wanted, but layer is easiest. So we've got those selected. I'm going to go up here. I'm going to click optimization, digital planting, and well, we set our row spacing. We can set our point spacing along those rows, number of trees per row, and well, we can change our symbology if we'd like. And here, just to kind of make it a little more obvious what's going on, I'm going to connect all these points as a line as well. So we'll hit OK. We'll let this thing work away. And we can zoom in here and we can see, well, as promised, we have a bunch of rows running up and down the hill. If we look to somewhere like this, where our aspect's changing, we can see that the trees, well, change direction with the slope. So say down here, we're going that way, and then up here, we're running that way. Again, all about kind of avoiding having really hard side hills in our plan. So we can see that now here, again, just to kind of make it a little clear, I'm going to just select those tree features. I'm going to make it so we don't see the line connecting them. So a little prettier when we do that in terms of the orientation of the trees. And then we can zoom right in and we can see, well, really where those trees change direction. Symbol is whatever we have shown for the symbol, and we are set. Now, I won't go through and do a full deliverable here, but like location, we can put together a multi-plot very quickly to capture what we'd like. So here we could start out blank. We can come in here. We could retrieve a previous screen layout if we had one. I don't think I have anything right on hand for kind of a perfect example of this, but let's switch that over to have our multi-plot. Of course, we can change our page size so it doesn't look quite as funny. And let's go RG. And there we are. So, and of course here we obviously change our scale, get it all prettied up, move things around to wherever it makes sense, but we'd very quickly have our documentation for this one as well. And maybe we want to turn off those polygons. And let's turn off these so we can see the imagery underneath them. And there we are. So with that, I almost kept it to the scheduled time, not quite, but that's that. We can open it up for a few questions.
Perfect. And I have one because I introduced that we could do it. So I might ask you to do it, Matt. How do you get the tree count?
Oh, all right. I'll just zoom out so we can see it. You don't have to zoom out, but I would right click, select feature. We could do it either by name or by layer. So these kind of system defined variables automatically go to a layer. Same with any other features that we bring in. So my shape files for my harvest units are a layer. I can add layers for things that I draw. But yeah, I'll come in here, select the layer I want. We've got all those features selected. So here, since I have them connected, each row is a feature, but each point on that row is counted as a point, and that represents my trees. So in this case, I've got 93,000 trees and change. So yeah, very easy to get that number.
Awesome. Very good. Okay, we have one question here about the cable harvesting course. So I might steal the screen and we'll put it up here on top of mine. Okay, so yes, one of our questions from the chat here, which is just how do you get to the cable harvesting course? And we certainly can send this out with the follow-up for the webinar, which is, yeah, you go to just softtree.thinkific.com/courses, and then you can get to cable harvesting. So this is one of a variety of courses that we have available. And again, if you are a client on support, even a student, you can get free course credits, as well as sometimes folks who are doing trials. So when you're at the page, scroll down, request a course credit. We can give you a coupon code to get in, make it free, and help you continue learning. Because yes, all of the topics we talked about today certainly have a lot more depth to them. So this was a very superficial introduction to each of the different components of forest engineering projects that you can use RoadEng for. And with that, I recognize we are over time. I might save a couple of these slightly more complicated questions for a follow-up afterwards, and we'll wrap up the live webinar here. So I just want to say thank you, everyone, for joining us today. Hopefully you don't have too much information overload going on. And yeah, we look forward to seeing you guys at another webinar in the future. Have a great rest of your day.